Okay, I think we can get started. Okay, so welcome to the second part of this subject. I think I already take half of the subject from Professor Zhang. Okay, so this subject is basically related to probability statistics and machine learning for engineers, and it's offered in CEE. Okay, we're actually curious because I see the class list. So basically, we see like different department, many department students from many departments actually join this subject. So we have CE student, right? So can you please raise your hand? One, two, think a little bit, and then FCE, LSGI, BRE, all those. And then how for others, which department are you from? ABCT? So what's our research in ABCT? Is more chemistry or anything?
Biomedical.
Biomedical. Then why you need this? Bioinformatics.
Yeah. Find out.
Okay, then why are taking the one that is in civil engineering, not in your department?
Because in our department, there is no course, there's no kind of course with
Okay.
similar one.
Okay. Okay, and the other department?
AP.
AP physics related, applied physics, right? So what research that is related?
Because my project is related to the
Computational method.
Yes.
So which is quite different from this. I'm assuming that you're talking about the 数值仿真, something like that.
Yeah.
But it's not offered here.
But we also interested into the statistics and machine learning.
Okay, okay. And other department? What AE? Okay, then AE, okay, engineering department. Any other? No, so okay, I kind of understand. So I think Professor Zhang mainly talk about the probability and statistics parts, and I think his view is more of a regression, from a regression perspective. I think it's a little bit similar to the bioinformatics approach, but I think his methodology is a little bit different, okay? Because he's more talking about the social perspective or people's behavior perspective, which you won't use. But the probability statistic part should be similar. So my part is mainly about machine learning. Okay, so I'll use the next several weeks to talk about the machine learning. Because this is a pure PhD subject, start from 6, so CSE6 something. So usually we wanted to make this subject super difficult because the outcome of this subject should be very related to your paper, right? That requires a lot of quantitative background that you should have. But based on Professor Zhang's feedback, it seems that the background is varying. So then let me just first check. So did you have taken any this subject today's subject I cannot change, but based on the survey results, I'm thinking of how to design the next few weeks. Okay, because this is a pure new subject. This is offered the first time ever seen. So this is the first offering. This is a new subject. We can design the subject based on your need or based on your requirement. So any subject that you have already taken related to machine learning in your past studies? No. I assume that you have did the master degree in somewhere. Most of the PhD students here, I think, have taken a master degree before, right? No? Direct entry? So anyone who have taken any machine learning related subjects, anything? Or can you just say some machine learning methods that you have already know?
Just very broad understanding.
What?
I just watched some video from online. I understand some training.
Okay. Okay.
Yeah, I learned by myself online.
Oh,
Learned course from Stanford.
okay. Well, machine learning.
Promotion.
Okay. what does it cover? For example, the decision tree, regression, clustering, what particular method?
particular method, like some algorithm, like XC boost and this.
Okay, I see. So usually when we talk about machine learning, we have two. So there are actually two types. Okay, so basically, one thing is that you know all those machine learning methods. Okay, and then you can apply those into your own data so that you get some results. So this is one type. Another type is you understand what's the advantage and disadvantage, what is a limitation, what is the assumption for each machine learning method, so that you know the trade-off, and also given based on your study, based on your data, you need to develop a brand new machine learning method by yourself. Okay, so that's two types. So this is one is more about apply. Okay, you are not going to develop any new machine learning method, but the contribution is in your domain. For example, in your domain in the past, it's used is a model based approach, but here you change to the data driven approach that give you some accuracy, that give you some improvement. So this is one type. Another type is that you want to develop some very some different learning schema, particularly for your task. Maybe I take an example of bioinformatics. I think you have you heard about LASSO? No? Yes. So this is a very famous method in machine learning, but this is actually developed by some people from bioinformatics. It's not pure machine learning people. So it's very simple. So basically, what they want to do is they want to build a linear regression. I think you know this now. Dr. John already told you. Okay. So basically, you want to develop a linear regression. So this linear regression, they want to use this in their studies. So what they want to do, they want in their case, the X is more about DNA. So different DNA, different genes. Okay. For example, you observe a lot of genes in someone's DNA, and then you list those as X. Whether this person has these genes or not, whether this person has that genes or not. So you have a super long variables that is related to this person's genes. And Y is some appearance. For example, this person may get some very rare disease, or this person may have a big eyes. So this is some appearance. So basically, what they want to do is they want to identify which gene pieces that lead to a particular appearance or particular disease. A very standard regression problem, right? But the issue is that you have a super large X, means that you have a lot of attributes or features. Okay, so in that case, I think Professor Zhang talked about this. So if you don't have enough data, then this becomes an underdetermined problem. So that's the case in this issue, in this problem, because you can imagine how many genes people has, right? Then what they are going to do is that they add some regularization to limit the regression. So that becomes a very famous method called LASSO. Okay, so maybe I skip the detail for the methodology. Later, if you have time, we can talk about this methodology. So you can see that this is actually developed by a bioinformatics, I think a professor, and it's now widely used in different areas. Okay, so I'm not sure which type of research that you are interested in or you want to do. So and when we design or when we want to open this subject, actually we targeted on the second one. Okay, we target on the methodology development. So that means you need to understand. For example, I can give you a list of machine learning methods, and you need to tell me which method has what assumptions, and it should be works better in some scenario. It shouldn't work better in some scenario. So that means you need to have a very detailed understanding of why you need this methodology, how you derive to this solution algorithm. So that requires quite a lot of background. Okay. Otherwise, what I can do is to walk you through several machine learning methods and let you understand what's the general idea. Okay. Then based on the survey just now, I think I have to mix a little bit. Okay, so I just try, maybe I just try to integrate this two. Okay, I gave you some famous algorithm and try to do a little bit of analysis or some analysis for you. The reason I do analysis here is that in some cases, if you write papers, whether you just write some equations or you need to write a lot of equations in your paper. Okay, so it's completely two different type of paper. So I'm not saying which one is good, which one is better. So both are good, but it's just different style, whether it's more methodological oriented or it's results oriented. Okay. Okay, so in the past, I will assume that we are doing the second one, but I guess it's way too much. So maybe I work a little bit back to mix these two. Okay, so today's lecture is quite standard. I just give you a quick overview and also basically a quick introduction of machine learning. Okay. So also another question. So any of you have taken another subject that also taught by me called urban big data? Please raise your hand.
I have taken
Last semester, then I did the teaching, right? For 4 weeks. You are not in the class, I'm pretty sure. Yeah, because it's early morning, so not too many people. So the first lecture will be largely overlap with that one. Okay, so bear with me with that. From the second lecture, I think I'll make a little bit harder than that one. Okay, so today's I think will be similar. I'm already okay. Okay, then let's get started. So basically, we are talking about so this part we are talking about machine learning method. Okay, so when we talk about machine learning, so basically it's about what is well, usually we have multiple names, no matter it's AI, machine learning, deep learning. So basically, it's referring to similar thing. Okay, so we want to use machine to learn. Okay, so I give you a quick background. I think you all know this. I just quickly go through. So I think in recent years, you definitely see that a significant growth in the AI markets. And in recent years, many new, especially in recent 3 years, you'll see a lot of very good applications that is from the AI perspective that is actually changing our daily life. Okay, so in general, when we talk about the AI market or when we talk about machine learning, it's actually a very complex industry. It has a lot of, it has different participants. So basically, we have some soft hardware that later we also need to talk a little bit because many machine learning methods is actually quite related to the hardware, and also. So we need to talk about the methodology and also the later applications. So maybe some more survey question. So I assume that most of your background is from engineering, right? Yes. Are you guys anyone from non-engineering background? For example, science. Science means mathematics, computer science. No. Okay. Okay, so when we talk about AI market, when we talk about I think you definitely read a lot of news related to AI or machine learning, and you definitely notice that the major player of this of the AI computation is 3. So basically, US, China, and EU, and Europe. Okay. So you see some countries that is falling behind. They have a good economy, but their AI development is quite far away. For example, Japan and Korea. Okay, those two are so basically they don't have a very good economy in related to AI. So the major 2 players is basically China and US. Okay. I think from the news you definitely notice most of the recent developments is from these 2 countries. And in terms of job opportunity, I think definitely especially last year, I'm not sure do you know the current salary for the AI related posts in mainland? Okay, for example, maybe I just give you some, this is not secret, so you can search anywhere. So in the past, when we talk about AI, why the AI is so popular, one major issue is that actually AI can make money in the IT companies. For example, in the past, the most important um, methodology or the most important function is called search and recommendation. Search and recommendation. It's so quick. Okay. So this is heavily used in every perspective. For example, if you are in Ali, in Taobao, then it can recommend some product for you. And then if you purchase, then it's real money. And for example, in TikTok, and the system will recommend some movies, some videos to you. And if you watch the video, and then there might be some advertisement. And if you can stay there for 1 more minute, that actually is real money. Okay, so basically the performance of machine learning method can be directly related to the money a IT company can make. For example, if you can, for example, they have very straightforward measurement. For example, I give you 100 recommendation for the product, and in the past, if you use an old algorithm, if you use old algorithm, okay, so you only purchase 5% of it. So out of 100, you only notice that this 5 is good and you purchase it. But if for the new algorithm, because the algorithm is better, so it's actually recommending something you really need, then maybe you purchase 1 more, 6%. So 1% increase. So you can imagine 1% increase in a large recommendation system, how much money you can make more. Okay, so that's we are talking about millions of users, right? So you can say that even one single machine learning engineer, if you develop a better algorithm that improves just 1% accuracy, this means millions of dollars income for the company. So that's why the AI engineer usually get a high pay in the IT company, because you can one single person can make a lot of money. Okay, so that's the old story. So this is all the story before the GPT, the ChatGPT. Okay, so after the ChatGPT, most of the application now they want to. So when they do search and recommendation, usually it's not using the large language model. Okay, so they have their own algorithm. But after that, becomes the era of large language model. So recent years, people are developing different large language model and application of large language model. I think maybe you have used some of the application. For example, they can help you to order the food delivery, something like that. Okay. I just give you some number last year. For example, in last year, in ByteDance, as long as you can get enrolled as a large language model engineer, so LLM engineer. So the average, the base salary. So I should say base. So I should say the startup salary usually is 1.1 million RMB per year. So this is the recent price. Okay, do you know why this is this high? Because training is even more expensive. So people are actually spending a lot of money on. So basically, all the IT companies they are spending a lot of money in this area. So this becomes a super hot area. The main issue is it has a very good relationship with IT company. So your research model, or your model, can be directly translated to the revenue. Okay, so that's very important issue. Okay, so because of this, I think recent 10 years, 15 years, we see a lot of development in this whole area. So maybe I give you a little bit of history. So do you know what's the first area that AI has significant advantage? Basically, it's CV related. Okay, so computer vision, CV. Okay, so this is actually the first area that's the AI has the most has a better advantage. So CV basically talking about using computer to understand the image and understand the videos. Okay, in general, we call it computer vision. Okay, so that relates a lot of tasks. For example, you may use this video to identify different objects and analyze, like, for example, vehicles and people on the road. And sometimes that is using to do some post estimation or the whole the counting of the people. And I think in many areas, it's also used to count some things and monitor whether there's some anomaly. Okay, so this is actually the first area that has been dominated by AI. So within the CV, there's a lot of tasks. Okay, so the very first task in the computer in the CV, we call it a image classification. Okay, so the task of image classification is very straightforward. Basically, we give you an image, and you put the image into a machine. Now think of it as an AI. Okay, you put the image into a machine, and the machine will tell you whether this image is a dog or it's a cat or it's a person or it's a building. Okay, so we call this task a image classification. Okay, so this is the very first algorithm that is conquered or that is solved by the AI method. Okay, so if we look at the accuracy table, so let me explain this table a little bit. So, in the old days, some professor, she's very famous, called Fei Li, in Stanford. They developed a database. So something like this. So you can see there's a lot of image, and each image is some object. Okay, for example, this is a building, that is a computer. So they develop such a data set, and then people basically are competing in this data set. So see which one's algorithm is better. Okay, so let's look at this table. So this data set is called ImageNet. Okay, and we are talking about the top 5% error. Top 5 error. What is top 5 error? So basically means I will let you to guess 5 times, and if you are correct in one of the guess, then you are correct. Okay, so I give you 5 chances. You can see what this image is about. Okay, so in total you have 1,000 in type. So basically you have your output is 1,000. So basically you should name one out of this 1,000 types, and then you have 5 chances to be correct. Okay, so if we look at the accuracy, okay, so this is 2010. This 10 means 2010. Okay, so back into 2010, the accuracy is actually pretty low. Okay, you can see that even I ask you to guess 5 times, your error is still 30%, around 30%. Okay, so you can see that in 2010, 2011, the accuracy is still this level. So a big jump or a significant leap is here. Okay, from 2011 to 2012. So this is the first time the neural network deep learning model has been used. So this is called AlexNet. So this is a very famous, very important milestone in the computer vision and also in the deep learning. So you can see that by using this model, they can improve the accuracy by around 10%. Okay, and then after that, people start to improve the deep learning model. So you can see that the accuracy, the error rapidly increase. Rapidly decrease. Okay, so just in 2014 or 2015, the error is already 6% something. So this is all. So this one, the 2015, this is almost human level. So 3% error. Okay. but this is just 2050. And now you can go back to think of when the AI becomes popular. It's actually the same time period. Okay, so it's mainly because of this model. This model starts a new era. Okay, so the 2011 and 2012. This is a very important timeline. Okay, so now, so this is 2015. So we are now in 2026, right? 11 years later. So do you know what is the current accuracy for the ImageNet? So the top, so recently we never see top 5 error because every model's top 5 error is 0. Okay, so now even the top 1 error is within 5%. Okay, I just ask you to guess what's the accuracy is still below 5%. Okay, so that basically means this whole task, the image classification, is completely solved by the AI. Okay, so now I think you'll see this everywhere. Okay, so the object detect, the image classification problem. Okay. After image classification, I think another task that is frequently used, maybe in your research, as long as you have some video that you want to analyze, usually the first thing you are going to do is called object detection. Object detection is a little bit different from the image classification. Image classification basically says that you give me an image, I give you a class. Okay. Object detection says that you give me an image, okay, and then I will give you the image with a lot of bounding box. This one is called bounding box, B box, bounding box. Okay, so each of the bounding box will have a label. Okay, so here you can see that for given this image, I have a lot of bounding box, and each of the bounding box is actually a image classification. Okay, for each of the bounding box, I tell you this is a car, that one is a bicycle, and this one is a traffic light. Okay, so for the object detection, you can see that it's actually 2 steps. The first step is that you provide the bounding box, and the second is that you do a image classification. So you can see that this one is it's definitely difficult than the image classification, right? But this one is much more useful in your video analytics. So basically, as long as you have some video data, usually people will do this one, object detection. Or there's another one that is even more difficult called object tracking. Object tracking is basically after you detect this object and then you track this object for a time period. Okay, so that one is used in video. So object detection is used in image. Okay, but so you can see, I think after the description, you can roughly understand which one is easier, which one is difficult, which one is even more difficult. Okay, so the object tracking is actually the fundamental technology for the autonomous vehicle. Okay, because so for example, Tesla driving on the road, at least you need to know where is the obstacle, where is the pedestrian, where is other people, where is other vehicle, right? So the Tesla is only using camera. So basically, the backbone technology is actually those computer vision technologies in Tesla. Okay, so I think you know the good performance in Tesla. Then you I think you roughly understand those methodology is quite dominated by the AI model. Okay, so that's the first area that is dominated by the AI model. And usually when we talk about the machine learning method, we actually the methodology is actually pretty unified. Means that all the methodology has the same input and has the same output. Okay, so for example, so this is a very important feature for machine learning model. So given a machine learning model, usually we give a task for the machine learning, for example, image classification, object detection. And once we define this task, this machine learning model's input output is already determined. So everyone will use the same input and output. Okay, and there will be some research group, they are so nice, so they will develop a data for this particular task. Okay, and then people can develop different machine learning method in the middle, and then they can have the unified input and output so that they can compare with each other. And then you know which one is better, which one is not good. Okay. So given this, so usually so basically, for example, if you just want to use machine learning, what you need to do is that you just need to know what task that you are working on, and then you just search the best model at the current time being. You just use that model. Usually will give you a pretty good result. Okay, so for those tasks, usually we categorize based on input. Okay, so we categorize based on the type of data. So what is the input data that you are looking at? So for the computer vision, the data is actually images and video. So those two are similar. Okay, image is just one image and video is just multiple image. Okay, so this is for the first type of the data that we work on a lot, video and image. Then we have other type of data. For example, the recent success is in language. Okay, so then the other there are many other applications that is actually related to language. Say for example, the translation and voice recognition; those are all related to language. I'm not sure how long have you been using the YouTube. So in the recent years, I think recent 5 years, the YouTube has a new function, the automatic captions. Okay, in the past we don't have this function. This is actually because of the development in the AI. And also, I'm not sure have you used the Google Translate or any translation 10 years ago? So the translation is super bad actually, but recent years, I think the translation is pretty very good, and you can directly use it in many cases. Okay, so that's all because you cannot people cannot find the best model to process the language related data. Okay. Maybe another question. So why? So you can see that these are the two major developments in the AI. So why language and image? Mainly because of those IT companies, they have the most data of language and image. For example, Facebook, they have almost unlimited number of images that they have, and also they have a lot of language data, text data. Okay. So in recent years, I think you definitely see that you have definitely used some large language model. If you haven't, you should do. So actually, I'm suggesting or I'm encouraging all of my students to do vibe coding and vibe writing. I'm not sure whether you are using it now. Okay, do you know vibe coding or vibe writing? You know what this means? Basically, you shouldn't write code yourself. If you want to write some programming, you should collaborate with large language model and let them to write. Okay, so it's much more convenient. And even though later when you write papers, usually now we suggest that you should so basically you should work with the large language model. If you write a paper by yourself, you're outdated. It's too slow. So now you can write a paper in 5 days or 7 days because of web writing. But you need to control the quality. But for grammar issue, for the consistency issue, you don't need to care about. Okay. So I highly recommend that you should set up a vibe writing and vibe coding environment, and because you're PhD students, and later if you want to go to find a job in mainland, then they are competing the number of papers. So you should try this. It's very I think it's very effective and can help a lot. Okay, so in addition to that, actually there are other very important tasks in machine learning in AI. One of this I just mentioned, the recommendation, search and recommendation. So the recommendation. So recommendation system is actually a embedded AI model, and it's used everywhere. Okay, no matter it's YouTube, Amazon recommending you a video or recommending you a product, or even in some social media, it can show you different posts. So those are underlying all those platforms. There should be a unified recommendation system. Okay, so this is super important for those IT companies in the before the ChatGPT. Okay, so I think every year hundreds of students go into those companies working on the recommendation. Okay, so this is a very important area. And so the recommendation system is also recent in the past. There are some other methods, but in the recent years, it's also dominated by the deep learning neural network. Okay, and then there are others. I think you've definitely heard about some. For example, you can use AI to play some games, and the most important one, most famous one is to playing the Go game, the AlphaGo. Okay, and similar methodology can be used to control the, for example, the air conditioning system, control the plasma reaction, something like that. So basically, these are all related to AI playing a game. Okay. Okay, so maybe later I show you this video. So this is actually a pretty interesting video. So basically, you can use AI to control the robots. Control, for example, the recent years, all the robotics control now is based on the AI. So people no longer doing model for the robotics. And this one is to use the AI to control the drone. Maybe I show you. That's it. The drone is here. So this is by reinforcement learning. Okay, so you can see that it can achieve this kind of FPV level control. So the control is actually very high resolution and very quick. Okay, so so basically we are talking about those like the original AI method. So what I'm talking about before this is all original AI method that has been developed by those computer science people. And those people, they directly collaborate with the IT company. Their research can be directly used in those IT companies to make more money. Okay, so that's the original algorithm. But then the AI has been used in all different areas. For example, in the urban system, because we're in civil engineering. So, for example, this is one that developed by Ali in Hangzhou. So basically, what they are doing is that they have installed a lot of camera in the Hangzhou city. So based on the camera analytics, computer vision, they can understand what happens within the city. If there's car accidents, if there anything, they can actually analyze from the model. They call this a city brain. So essentially, you can imagine that they try to even manage the city using the AI. And similar idea has been developed in other IT companies. So actually, Jingdong has a sector, and basically they want to do this kind of platform. And they call it, in Jingdong, this one is called CTOS, City Operating System. Okay, and they don't sell to you, they sell to the government. For example, they can sell to a city government, and if the government use their platform, they just pay a subscription fee to the IT company every year. Okay. Similarly, for example, in Google, they also have a lab called Setwork Live that is related. That is also using some IT technologies to serve for the civil systems. So there are actually many applications in different areas. So here I'm talking about something more related to the urban system. And I think you are taking this subject in your area. There definitely something that is using, if you use AI, you can get some more benefits. So people now are promoting this. So then you can see that the AI methodology, this AI becomes popular in recent decades, in recent 10 years. Okay. So this is some study from Jingdong. So basically what they are doing is that they have collected like multi-source data including the temperature, traffic, human mobility, all those things, so that they can model the air quality for this area, something like that. So they did quite a lot of this type of research, so that and then they will sell to the local government. Okay, and in the transportation area, so the one of the very important application in recent years is about autonomous vehicle. So this is actually you can see that it actually incorporates the computer vision and control of the robots. So this is actually a very complicated integrated system that use every aspect in AI. So later, if we have time, we can discuss more. So here today, I think I just show you this video. Maybe you haven't heard about this company, Argo. Argo is a US company. I think they are doing well, and then they purchased by some German company, Benz or something. Basically, they purchased by a car manufacturer. So they are building the autonomous system. Okay, so you can see that the first thing that you will have a lot of sensors in the car. Okay, and then those sensors can perceive the surroundings and then they can drive by themselves. So this is related to the robotic control, computer vision. Yeah, I think you'll definitely see many of this type of videos, Tesla or Wenjie, Huawei. So they have a lot of similar videos. Okay. Okay. Okay, so there's a lot of other applications. This one I think is pretty recent and pretty interesting. The recent years, the satellite image analytics are also used. So you can think of the satellite image as a super large image, and then you can use AI, computer vision to analyze it. So this is actually heavily used in the Russian-Ukrainian war to, for example, assess the level of disaster and assess the road accessibility. There's a lot of things that you can do using this kind of images and analytics. But because this is super large, usually this is cannot done by human. It's done by AI scanning. Okay, so basically in Hong Kong, because we are from the FC department, so engineering department, then there's actually a blueprint developed by the Hong Kong government, which is called Hong Kong Smart City Blueprint, that actually relates to all kinds of things that they want to enhance in Hong Kong to make use of the data and AI technologies. So here, it's not just about civil engineering, so it's about transportation, about smart living, environment, and ecology and people. So there's a lot of things. Okay. Okay, so that's basically some overview. So you can see that the this AI technology is kind of leading. Basically, it's mainly used in those IT companies to make money, but in the academia, more and more people find that AI can help their own research, so that they try to use it, try to adapt it to it. Okay, so because of that, I think in today's lecture, in the next few weeks, I will go at least let you understand what is the fundamental setting, what is the basic knowledge in the machine learning, and then I will give you several algorithms additional and also their analysis to get you a flavor of what a machine learning model should look like. Okay, and so we're not talking about any applications. We're only talking about methodology. Okay, then you should think of how this model can be useful in your research. Okay, so that will be in your project report. Okay, so basically we are going to talk about how to use AI and machine learning, what is different methodology in AI and machine learning. Okay, so basically, I think those logistics are similar to the Professor Zhang's. We were basically teaching is here face to face, and we do have office hour, or if you have any questions, just let me know before or after the lecture, or just send me an email. And for the slides, we do have two versions of the slides. You can see that I'm writing quite a lot. So before the lecture, usually I'll upload a clean version, and after the lecture, I'll upload the annotated version. And also, the video recording I will upload to the Blackboard, and we will have one homework. Okay, so that will also be on the Blackboard. Okay, so you just after you write the answer, you can write in your computer or you can handwritten. After you write everything, you just scan it and upload to the Blackboard. We don't accept hard copies. So everything is electronic. Okay, so for those things, I think I don't need to repeat. You are PhD students, I can see you do. So for those things, you are very familiar. Okay. So here is a schedule. So you can see that today I just try to answer the first question, what is the data, what is a different type of learning. And then next 2 weeks, we're talking about some more method, okay? And then I will spare 1 week for neural network, because in recent years, when we talk about machine learning, actually there are two different types. When we talk about machine learning, it's not necessarily the neural network or deep learning. So there are many other methods that is also machine learning. Maybe you haven't heard about it or you haven't used about it. For example, decision tree. Have you heard about it? Supporting vector machine. Have you heard about this? Logistic regression. The random forest. It's not. And some boosting. There's a lot of boosting, other boosting, actually boosting. So a lot of boosting. So those are, we call it machine learning method, but those are not neural network. Okay, neural network we are talking about. Basically, neural network is a very large group of study. They are using the neural network as the backbone, but there are a lot of traditional machine learning methods. Okay, so if you are interested, what are the traditional machine learning methods? There's a very good website. I highly suggest that you just, if you have time, you just look through it, which is called sklearn. You heard about this? No? So this is a Python package. Okay. It's called sklearn. Okay. So this is a Python package. You can just install it in Python, and then you can run it. Okay. So this package includes most of the famous traditional machine learning methods. Okay. So you can see that it has different types. So classification. So later I give you more detail what is different type mean. Okay. So for example, going into the classification, it gives you. Okay. So this is supervised learning. So given this supervised learning, there's a lot of algorithms, method. Okay. For example, I just mentioned the lasso here. Okay. So this is ridge regression, lasso, elastic neck. So those are machine learning method, but not neural network. Okay, so I think sklearn has covered most of the methods that you're going to use. Okay, but this one is super old. It's already very outdated because in recent 5 years, particularly after the ChatGPT, most of the task is dominated by deep learning. Okay, so you just name all the different applications that you see in recent years. It's dominated by deep learning. So, so that's why now if you are saying that you are doing machine learning, most of the time we just view you are doing deep learning. Okay, so recent years this tool is almost equivalent. Machine learning almost equivalent to deep learning because not too many people are working on other learning methods. Okay, but this is not the story 5 years ago. 5 years ago, deep learning is not dominating. People are still working on different learning methods, and they don't know which one is better. But now it seems that many evidence shows that the deep learning is so good. So more and more people, they just don't study other methods. Okay, so they gradually switch to deep learning. Okay. Okay, so you need to be very clear. So when we talk about machine learning, it's a large concept. When we talk about deep learning, it's more related to the machine learning model that is using neural networks. Okay. Okay, then we will have a quiz on July 1st. Okay, before the quiz, if we have time, then we just talk about some advanced topic. And then the next 2 weeks will be the project presentation. Okay, so basically the project presentation, we just ask you to present your current research, and you should use no matter probability, statistics, or machine learning method in your research. And you need to submit a report. The due, I think Professor Zhang has already tell you, and I create a online submission portal. The deadline is April 16th. So once you finish your report, you just submit here. Okay, and please submit in PDF form. Okay? So don't submit the Word format. Just convert to PDF and submit in PDF. Okay. And also another thing is here, we will have one homework. Okay, we will have one homework. I think I will announce maybe next week, maybe the week after next week. So basically one homework. Okay. Okay, so maybe let's take a break and we move on to the main context. Okay, so if you have any question, let me know. Okay, so let's take a 6 minute break and we can. Okay. Okay, so we move on. So basically today's task, I think is mainly the data and type of learning. So this part I think is quite overview. I just quickly go through. Okay. So when we talk about machine learning, AI, so those concepts actually they are mixed together. Very hard to differentiate. So let me try to give you a definition. So later when you choose the wording, for example, later whether you want to use machine learning, deep learning, AI, you should choose a good scenario to use. For example, in your paper, which terminology that you want to use. Okay, so when we talk about AI, usually we are talking about the entire machine, the entire system. Okay, so AI is basically the intelligence demonstrated by the machine. Okay, so basically it's so the another so basically this is ops to the natural intelligence, for example, the human intelligence and animals intelligence. Okay, so machine intelligence is mainly talking about how the machine shows the intelligence. Okay, so when we talk about AI, this term, we are talking about that the AI, the machine has certain level of capability that human have. Okay, so here we summarize it into 7 perspectives. So as long as the machine has one or more perspective of those, then we say this machine is a AI. Okay, so when we talk about AI, it's more related to a machine. No matter this machine is a server or is a robot or is a vehicle. So AI is more related to something that has intelligence. Okay, so this 7 perspective, the first one we call it perception. Okay, means that similar to human, we can use our eyes and our nose to understand the surroundings. The machine should have some ability to understand the surroundings. For example, the autonomous vehicle, they have the sensors, they have LiDAR camera to understand the surrounding. And the robot, they also have camera to understand, to look at the surroundings. Okay, so this is perception, the capability or ability of perception. Okay, the second one called reasoning. Reasoning basically means that you can derive something, okay, from A to B all the way to C and D. Okay, so this is reasoning. Okay, the third one called control or manipulation of motions. Basically, you can move something. Okay, no matter it's a robotic arm or a traffic signal that can change the traffic timing. Okay, so something you can count. So that those machines they can physically control something. Okay, they can change something. This is also a one perspective of intelligence. Okay, so planning, I think similar to the reasoning, but planning is more like planning your motion, planning your action. Okay. So another one, communication. So if you have multiple AI, multiple robot, they can communicate with each other. Okay, so I think this is very easy to understand. And creativity. So somehow it has some level of creativity. For example, this is a popular website called this person does not exist.com. So basically in this website, it generates a lot of face, photo of the face, but those people are actually does not exist in the world. They're just generated by the generative AI. Okay, so you can use this in anywhere without copyright issue. Okay, and also in many recent applications, no matter TikTok or Instagram, you definitely have some function that is doing like this. You give them one image and then they can generate some other the image in different styles. So that basically this is about creativity. Okay? Your machine can create something new. Okay. So last one, this one is learning. I think this one is very important, and most of the time, the AI has this capability. Learning basically means that it can getting better and better given the feedback. Okay, so it can evolve. I also have one video to show you. I think this is very interesting video. So this is in YouTube. You can definitely find it. So this is basically talking about a car. And for this car, they have 5 distance measure. They have 5 distance measure. So basically it measure this 5 distance. Okay, so this 5 distance is here. So it becomes the input of a neural network. And then the neural network just output 2 things, left and right. Okay, so basically you just want to use this measurement to control the vehicle, whether turn left or turn right. To control the vehicle does not hit the wall. So this is trained by iteration. We shouldn't say iteration. So here it's called generation. So it's trained generation by generation. Okay. So you can see that the first generation, those vehicles are actually behave very badly. So it's actually learning. So basically your machine is gradually learning. So there are some machine learning method behind. Okay, so later I give you more detail what's the machine learning method, but you can see that up generation by generation, it becomes better and better. Okay, but there's more challenge, and you see some more challenging situations that they fail again, and then it just keep evolve, keep learning. Okay, keep learning. So later you can see that this is 15 generations. You can actually drive better. Okay, you can drive further. Okay, so it fails in a bottleneck, but this one is success. So you can see that it can drive outside. So after a long time, so this is 46 generation. So you can see those vehicles are actually getting more and more better. Okay, so most of them, they are actually getting, they are performing well, and many of the vehicles, they can actually reach the destination. So this process, we call it a learning process. Okay, so basically you train a AI that is controlling the vehicle, and this whole process we call it a learning process using some machine learning method. Okay, so when we talk about the AI, most of the time your AI should have this kind of learning capability so that it can achieve the perception, reasoning, planning, those capabilities. Okay. Okay, so when we talk about the history of AI, the AI, this term is super old. It's actually by the Alan Turing in 2015 something. Okay, and in the old days, when we talk about AI, it's more like some so here is some symbolic AI. It's basically, for example, to help you to derive something. So this is nothing about machine learning. It's just pure AI. And then the development of AI is also not very smooth. You see this winter. And then in the 1980s, there's a very famous topic called expert system. This is also kind of an AI system, but I think it's still not learning. It's still AI. Okay, and then gradually we move to the recent era. This is more talking about the deep learning so the deep learning achieves AI. So basically we are using deep learning to learn to make the AI evolve to build this AI machine. Okay, so you can see that it's something like this. Okay. So because of the ChatGPT, so recent years we are talking about a new concept called AGI. artificial general intelligence. So AI, usually you have a task. For example, I want to build an AI model that is particularly for image classification. I want to build another AI model that is doing something. But AGI is a general concept. Basically, the AGI means that you have some machine that can mimic, that can learn to accomplish task that human and animal can do. So we don't specify the task. Okay, so this is general. Okay, so that is called AGI. So the ChatGPT, some people believe that the ChatGPT achieves certain level of AGI. Example, this is a figure, and you can see that the ChatGPT can do well in multiple different tasks that include math, writing, verbal writing, statistics, biology, psychology, quantitative, GRE, and also writing and physics and the language and those things. Okay, but it's not doing well in English language, literature, and those things. So you can see that this is already beyond one single AI model. Usually, one single AI model has a specific task, but the ChatGPT, the large language model, seems to have a generalized ability in multiple tasks. Okay, so some people believe that there's some certain level of AGI. Some people don't think this is AGI. So, but this is something that we want. For example, later, if the large language model become even better and it can do well in most of the tasks, then this is actually a AGI that can replace human in many scenarios. Okay. Okay, so that's basically AI. And when we talk about all the AI method or all the machine learning method, the first thing we need to be very clear is about the data. Okay, so no matter which type of AI model or which type of machine learning model you need to train or you want to learn, it's actually learning from the data. Okay, so the first thing is that you need to understand what data you have and how you can formulate your data. Okay. So in the old days, maybe in your high school or in your undergrad study, you haven't. I'm not sure if you still remember what is the first what is the first computer that is developed, which is called ENIAC. Right? I'm not sure if you still remember. So this is actually a photo of ENIAC, and maybe you don't know. So the question is, do you know which part, which one is the computer? It's actually the whole room is one single computer. Okay, and at that time, actually people does not have a keyboard and mouse. Okay, so how do you run the machine? It's basically using this kind of tape. Okay, this paper tape. So what you are going to do is that you just make holes in this tape. So you can see that it has different holes. Okay, different holes has different meaning. Okay, and when we talk about programming, what are we doing? We're actually making those holes, drilling these holes in this tape. Okay, after you make a tape, you drill those holes, and then you input this tape into the machine, ask the machine to read, and then the machine will output another tape. Okay, so you just read those tapes so you can understand what is the output. So that's a very, very early stage computer. So basically you input a tape and output a tape. Okay, so given that idea, so you can see that no matter what type of data that you have to translate it into a tape. Okay, so nowadays the things actually doesn't change too much. So what we are using now, we are using some HDD and solid disk. Okay, so for example, the HDD is something like this. So it's basically a disk. Okay, and the disk has a lot of region, and those regions basically is either north to south or south to north. So basically different So so different direction. So those representing 0 and 1. Okay, and all those actually located in this disk. And something is the layout is something like this. So you can see that even this disk is still a tape. It's just this tape is on a disk. Okay, when you read it, you're reading from like this. Okay, so it's still a tape. Nothing different. Okay, and you make a hole, it's 1, and you didn't make a hole, it's 0. It's also the same as this tape. Okay, so the computer has changed a lot from the paper tape to the hard disk, but actually the input and output does not change. It's still 0 and 1. Okay, and for this one location, this one location, we call this a bit. Okay. Okay, so this is the smallest unit in your computer. Okay, no matter we're talking about a tape, a HDD hard disk, and I'm not sure you know the solid disk SSD. So the solid disk is something like this. So basically, there's a lot of basically there's a cube in the solid disk, and in this cube there's a lot of location. Each of the location can store 0 or 1. Okay, so it's still similar to the disk. Okay, so basically, each of the location that stores a 0 or 1 is a bit. Okay. So I think I guess you have learned how to do the binary conversion, right? Yes, I think you have learned this, right? Given you for example, 10 in decimal, can you convert this into binary, right? I think you can do this, right? So you can see that given if you give me a number, I can actually convert it into a binary. Okay, I just give you maybe one example. Let's say 1111 1111 in binary. What does it represent in? So basically, this refers to 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. So it's basically 8 plus 4 plus 2 plus 1. So it's 15. So 1111 referring to 15 in decimal. Right. Okay. So this is so here you can see that if you give me a number, I can convert it to integers. Sorry, I can convert to 0 and 1. Okay, and I'm not sure. Do you know how you can convert a float, for example, 2.3 to binary? So this is we call it a floating number, FLOAT, floating number. So there are some standard how you can convert the decimals and also real number to a floating number. Okay, so they're standard. Okay, basically you can convert every numbers into the binary. Okay, then question, how about language? How about language? For example, give you a email, how the machine can read a email. The machine, so as I just mentioned here, you can see that the machine only reads 0 and 1. So you should convert everything to 0 and 1. So you should convert everything to number. The machine learning can only deal with numbers. Okay, even though we have ChatGPT, those can deal with text, but underlying model, they can only deal with numbers. You should convert everything to numbers, no matter what type of data you have. As long as you want to use machine learning, you should know how to convert those things into numbers. Okay. So let's talk. So for example, for the text, there's a very traditional, old-fashioned way to convert into the binary, which is called ARC table. I'm sure you heard about this. Yes, in your undergrad computers courses, you should have this one. Okay, so basically, we say that we want to use 8 bits to represent a character, English character. So 8 bits means that you have 8 locations. Okay, how many combinations that you have given this 8 location? So 2 to the power of 8, right? So which is 256. Okay, so given this 8 location, you have 256 combination of this 0 and 1. Okay, so basically people they just give each of this combination a meaning, which is called ask table. Okay, so here basically says that the first one is means none and all the way to the last one. So this is 128. So we call it the lower part, and also we have upper part. This one. So low ask and high ask. So in total, you can see that you have 200, 0 all the way to 255. So 256 combination, and each of the number representing one specific character. Okay, for example, here I think the most used is this area, the capital letter A B C D E, all the way to the lowercase a b c d e. Okay. Okay, so that means in your computer, if you store one sentence, actually they convert those characters to the 8 bits. Each of the English character convert to 8 bits, and then it can be stored in the computer. Okay. So now maybe you have a question. So this you can see that this only contains the English character. Okay, for example, what happens if you want to store the Chinese character? So there's another table called Unicode table. This is much larger and it requires more space for each of the character. So the Unicode table contains not just Chinese, Japanese, and Arabic. They basically contains a lot of different characters. Okay. So sometimes I think you'll notice you may encounter some issue. For example, you open a file and you'll see a lot of character that you don't understand. It's usually because you didn't specify the correct table. For example, this is originally by Unicode, but it's opened by an ASCII table. Then you'll see a lot of characters that you never see. For example, this area. Okay. Okay, so some basic knowledge. Because you are doing programming, you are doing AI, you should get some very basic knowledge of computer. You know how you run your model. Okay, so like I just mentioned, so the smallest unit we call it 1 bit. Okay, so then 8 bits, so 8 location equals 1 byte. Okay, 1 byte. And then 124 bytes equals 1 KB. 124 KB equals 1 MB, and 124 MB equals 1 GB. I think this area you are familiar. KB, MB, GB, TB. So you use in your personal computer every day. Okay. So why 1024? Basically, 2 to the power of 10 is 1024. Okay. So they basically just use this number. Okay. Those are defined. Okay. So just people are following this procedure. Okay, so in your personal computer, usually it's GB or TB level. But if you look at the real world data, for example, the YouTube or Netflix is actually in PB level or even TB level. PB and EB level. Most of the time it's in PB level. So I just leave this figure for you to look at. Okay. So you can see that in general, all those data should be encoded into a so eventually those data should be stored in your computer memory. Okay, so it should be 0 and 1. And our machine learning model is doing similar things. We need to convert no matter what type of data to a very numerical settings. Okay. So here, let me give you some brief description of the data. So basically, the data is, when we talk about data, it's a collection of facts. Okay, so it can be measurement, observation, words. And basically it can be two types, or qualitative or quantitative. And qualitative is more like a description, and quantitative is just it's numbers. Okay, and when we talk about qualitative and quantitative, there are also two types. Usually we call it discrete or continuous. Okay, so I think it's easy to understand. I just write this to ensure that we are on the same page, same terminology. Okay, so there are some example of qualitative, quantitative data. Qualitative is more like some preference, like or dislike, some severity, very severe or possible severe, something like that. And quantitative is just a number. Okay. Okay, so then this is a very important. This is very important concept. The first concept we met. So we talk about data, right? So usually when we talk about data, we should talk about the number of data and the dimension of the data. Okay, so given different type of data, we should unify it into a single format. Okay, so this is a baseline for using the machine learning model. So let's give you several examples. For example, this one. This one is a typical survey. So basically you have multiple questions, right? Each of the question you have different choice. Okay, so this is a survey questionnaire. And suppose that you have collected survey data, how you can format your survey data. So what we can do is, so basically we can format the survey data into a table. Okay, so this table, we have each row representing different people. We have P1, P2, P3, so different people. Okay, and each column representing different questions, Q1, Q2, Q3, all the way different question. Okay, and so basically the first person answer question Q1, maybe A, B, C, D, where we can represent by 1, 2, 3, 4, for example. 1, maybe 2, maybe 1, maybe 4, something like this. So fill up this table. So each of the row representing one person, each of the column representing one question. Okay, so here, let me give you the definition. So in machine learning field, by default, if we don't see any, if we just use it, so this is by default. Usually we don't change this default. It does, we define the number of data being the number of row. Okay, we define the dimension of the data being the number of column. And by default, the number of data is represented by the by n. N refers to the number of data. D refers to the number the dimension of the data. Okay, so those characters are by default N and D. Okay, so essentially you can see that eventually you'll have a data matrix that is N by D. Okay, so this is a survey data. Let's do another data. For example, we talk about sensor data. Let's think of there's a area, and in this area you have multiple locations that you measure for example, let's say we measure the PM 2.5. Different location we measure the PM 2.5, and then we want to record the data into a table. So what is the row of the table? It can be sensor 1, sensor 2, all the way to sensor N. Okay, and what is a column? Say for example, we measure the data every 5 minutes, and then the data will be 0.0, 0.05, all the way to 23.55. Okay, so how many columns do we have? We have 288. So this equals to 24 hours times 60 minutes divided by 5 minutes. Okay, so I have 288 columns of the data. And each of the sensor, we can record what is the PM 2.5 at that time. Okay, so here you can see that you have So you can collect the data into a matrix. Okay, so this is 1 day. This is 1 day's data, right? How do we collect data in multiple days? Okay, so we have 2 versions to do it. For example, what we can do is that we can have a super flat matrix. Okay, for example, this part is day 1. This part is day 2. And each of the day we have 288 columns, and still we have all the n sensors. Okay, so this is a flat matrix that you have the data, you can record the multi-days data. So that's one way that you can do it. Another way you can do it is that we can actually record the data into a 3-dimensional matrix. Okay, so this is n, the number of sensors. And then this is 288, basically record the data in 1 day. And then you have another dimension. This is the number of days. So you can imagine that in 1 day you have a matrix, right? And then in the second day you have another matrix, and then you stack these 2 matrices together. And in the third day you have another matrix, you just stack it. So eventually you have the 3D matrix. Okay, I guess you can understand this. Yes. Okay. So this 3D matrix, usually we don't have this name, 3D matrix. It's not a valid mathematical concept. We have another name for it called tensor. You heard about this? Yes. Okay, tensor in Chinese called 张量. Okay, so you think of this as a generalized concept. Matrix is actually a special type of tensor. Okay, and tensor can be multi-dimension. It can be 3-dimension, 4-dimension, 5-dimension. So you can, for example, if you consider month, year, you can have 4-dimension, even 5-dimension. But 4-dimensional matrix you cannot draw it on the paper. Okay, you can just imagine. Okay. So here you can see that once you have some data, you actually organize the data in this way. Okay, so no matter what type of data, you want to formulate it into a data matrix. Okay, so let's do something that is more complicated. Let's say an image. Okay, how do you convert an image to something that you have like this?
Pixel and color.
Okay, what?
Pixel and color.
Okay, pixel. Okay, so basically, that's some fundamental knowledge you need to know. Given an image, I think you'll definitely watch YouTube or those things. Do you know what does 1080p mean? Okay, I think you use this every day, right? So nowadays, the video, your YouTube, the video, you know this is about the video resolution, right? What's the actual meaning of this? 1080p means that this image is 180 pixel times 1920 pixel for this image. So basically that means given this image, you have 1080 row and 1920 column for this image. And each of the location is actually a pixel. This is a pixel. Yeah, SEL. And this pixel has 3 different color, RGB. Okay, so RGB color, basically the RGB number ranges from 0 to 255. Okay. Okay, so given a image, how many numbers that you have? How many variables that you have? Basically, it's 1080 times 1920 times 3. This is the number you have for one image. Okay. Then, let's say we are doing a image classification problem. Image classification, you have a lot of image. Okay, for example, you have n number of image. Okay, So you have n number of image. And then what is the dimension of your data? So here you have n number of image means that each data is one image, right? Because your machine, the input of the machine is an image. So that means that one data is one image. Okay. Then what's the dimension? What is the dimension of your data? It should be 1080 by 1920 by 3. So this is a super flat matrix, but it's still a matrix. N by D, D equals 1080 by 1920 by 3. Okay, so that means you actually flatten this whole tensor, three-dimensional tensor, into one single row. And you put this row here. It's a super long row. Or you think this is too ugly, what you can do is that you can do a four-dimensional tensor, which is n by 1080 by 1920 by 3. Four-dimensional tensor. It's okay. It's the same meaning. Okay. So you can see that no matter what type of data that you have, eventually it becomes a matrix or it becomes a tensor. Okay. So let's do something that is even more extreme. I think you know how to do image, you know how to do video. Okay, same idea, just more even more features. So something that you don't know is in ChatGPT, for example, you input a sentence, you input a text. How you can convert a text into a vector? How you can convert a text into the matrix? Okay, so in ChatGPT, I'm not sure are you very familiar with that. Usually we don't talk about we talk about token. Have you heard about this term? Okay, so basically charged by token. Okay, token is something you think of it as similar to word. Okay, so in general, all those large language models they have a vocabulary. They don't use this term. I just give you some term that you understand easily. So basically, they have some vocabulary. Okay, say for example, DeepSeek. DeepSeek has a vocabulary. Usually, this vocabulary is in billions. Okay, so it's in dimension of billion dimensions. So this is a super long vocabulary in billions. Let's say it's 1 billion. Okay, this vocabulary basically has different tokens. It basically stores different token, or you think of it as a word, different word. For example, is I, and I, you, me, something like that. So basically, it has a super long list of the token. Okay. Then, what you can do is that, for example, I can say, let me input a text. I like you. Okay. Then I can search what is token. So I is a token, right? I can search which location the token is. Okay, in this vocabulary. So basically, I can represent this token, this I, by a 1 billion dimension vector. 1 billion dimension vector, and so other locations they are all 0. Only the location of I being 1. Okay, so this vector representing the word, the token I. Okay, reasonable, right? Reasonable. So like, similarly, you have another vector. Those vector has a lot of all zeros, but there's only a 1. This 1 indicating that this vector representing like. Okay, similarly, you have another one. So we call this approach, we call it one hot encoding. One hot encoding basically means that there's only one. Others are all 0. So you can see that by using this vocabulary, you convert a sentence to multiple vectors, right? You convert the sentence into multiple vectors. And then you can connect all those vectors into a longer vector. So remember that the ChatGPT has an input limitation, right? ChatGPT has most of the large language model has an input limitation. So here, let's say I set a input limitation to be k. You can input maximally k tokens. Okay, now I can translate a sentence, no matter what sentence you have. What the first thing I'm going to do is to do, we call it padding. Padding means that you give me a sentence and then I just add empty all the way to the k location. Okay, I need to make sure every sentence has the same length. I do padding. And then every word, so now all the sentence has keyword, key tokens. Okay, no matter you have key token or not, I will add them to key tokens. Okay, and then then this sentence can be converted to a k billion vector, length vector. Okay. So each of the token is 1 billion, then k token then is k billion. Okay. Then you still, so for example, you have you say multiple language, then I can put n language. Multiple sentences. Then I say I have n sentences, and each of the sentence is k billion dimension. Okay, so this is strict. So you can see that no matter what type of data you have, even though this is super complicated language data, the conversion to the data matrix is very straightforward, completely brute force. Okay, so you just convert everything into the same data format, which is a data matrix n by d. We just call this a n by d matrix. Okay, very universal. Okay, so a question when we talk about the maybe some concept when we talk about big data, right? So now you have a better understanding of the data. Then what is big data? So if we talk about big data, are we talking about n is big or d is big? Okay, so some other so I just want to highlight some concepts. So for example, if you are processing the image and processing the language, you can see that by my definition, by natural, the D is super large. Okay, naturally, D is super large for image and languages. Okay, and for some other, for example, survey data, the D is actually not that many. Okay, so usually when we talk about the big data, it can be N big or it can be D big. But most of the time, I think the big data, we're talking about N and B, N and D are both large. Okay, so this is one concept, and another one. So here you can see now, no matter what type of data that you have, we always say that this is an X matrix that is N by D. But so N is the number of data, and D, I'm not sure, Professor Zhang, which name is using. In linear regression, how do you call the independent variable? Which X, any name for the X?
X1, X2.
No.
So this is it usually has multiple names. Okay, so in statistics usually it's called attribute. I'm not sure whether he's using this attribute. Okay.
Independent variable.
Okay, so independent variable, that's one name. Okay, so attribute, this is another name used in statistics. In machine learning, usually we call this a feature. Okay, feature in Chinese 特征. Okay, but this three is actually the same thing. It's basically referring to the different dimension of the X. Okay, in machine learning, you usually call it feature. Okay, so here you can see that we basically have an N by D matrix. Okay, N by D matrix and N number of data, D number of features. Okay, N number of data. and D, number of features. So I just want to give you one more definition. So when we talk about features, usually we say there are two types of features. We call it dense feature and sparse feature. Okay, so dense and sparse is talking about the information. So whether this feature contains a lot of information or contains very little information. So let's talk about the image. For the image, each feature is just one pixel and one channel of one pixel, right? That are in some specific channel, specific pixel. So that basically means that this pixel contains very little information actually, right? So you need to integrate a lot of pixels that you understand this is a cat or this is dog. But this single feature contains very little information, right? In this case, we call this a sparse feature. It means that the information contained in those features are very sparse. Okay, language and language is also a sparse feature because you have a lot of zeros. Okay, but what are the dense features? For example, the questionnaire survey. Each of the question answer is actually contains a lot of information. So those are the dense features. Or you think of a, for example, another example in the user registration. For example, you go to a new website and you need to register yourself as a user. So you're going to input a lot of data. For example, what's your age, what's your location, something like that. And how the websites, how the IT company they manage those data. You can imagine this is also a matrix. N is number of user, and the feature includes like age, gender, location, something like that, right? So those information is quite dense. The age, gender, those information contains a lot of those data contains a lot of information. Okay, so why we are differentiate dense information and sparse information? Because usually the model used to process the dense information and sparse information is very different. Okay, you can imagine that if you are working on a sparse information, usually you need to integrate the information first. And so you need to make the model smaller. Otherwise, it's too complicated. Okay. Okay, so that's terminology. Later, maybe we are going to use it. Okay, so here there's just notations I think I have already mentioned. So we talk about the data, and then we can see data sample, data point, sample, and point basically is referring to the same thing. Okay, and by default, we are saying that the number of data is n, and by default, we are using xi representing the i's data from 1 to n. Okay, and n is number of data, and by default, d representing the dimension of the features. Okay, so those are the default terminology that you see in different papers that you usually, as long as you are you have been trained in the machine learning profession, you should use the same letters, okay, to make sure that the paper is easy to understand. Okay, so later, if you are working on some machine learning paper, just reserve the n for the number of data. Okay, don't in some this happens in a lot of engineering domains because maybe you use n in different in your domain, it has a different meaning. Then you don't use n as the number of data. Then you have to be very explicitly explained. Okay. Okay, and then we have a, you can see that no matter what data you have, you can formulate it as a X matrix, which is n by d. Okay. So I think I mentioned how you can formulate this one and how you can formulate this one. So in general, the table formatted data, as long as this data can be opened by a Excel, this is by default a matrix, right? As long as the data can be opened by Excel, then it is definitely a matrix. And for those data that is not opened by itself, for example, the image, I already show you how you convert it into a matrix. Okay. So I think I already mentioned this. For example, this one is the example that you have different sensors in a building. And those buildings, they are vibrating. So you can collect the data, the vibration data in a building. Then it can be formulated as a matrix. Okay. And I think I'll also cover this part. So given an image, you can see that you have multiple pixels. And those pixels can be converted into a vector, can be converted into a matrix. And then you can flatten the matrix into a vector to get a vector. So I assume that all of you are using Python, right, in your research. Any other programming language you're using? R, and any others? Okay, so MATLAB, anyone using MATLAB? I guess it's already, okay. So I just want to say one more thing. So I just mentioned here, you can see that this is a matrix, right? So each of the pixel is 0 or 1. So this one is we don't use RGB, we just use color or not color. Okay, it's also okay. So you have a grayscale image, no color of this image. Okay, so here you can see that this is 16 pixel by 16 pixel, 256 pixel. Okay, so essentially this is a matrix. And then I want to convert this matrix into a vector. Do you know which function you are going to use in Python to do this? Maybe I give you another. So maybe I give you another. I make the question more explicit. Okay. So let's say we have a matrix that is 1, 2, 3, 4. I ask you to convert it into a vector. So you actually have two versions. The first version is 1, 2, 3, 4. Another version is 1, 3, 2, 4. Okay. So if you are using Python, which one it should be? This is a very standard interview question. If you want to interview some machine learning related post, which one? Any other? It should be the first one. Okay. So there's no right and wrong. This is just by default. Okay. So there are two types of programming language, which we call is a row major or column major. So the row major programming language will convert by row, and column major programming language will convert by column. Okay, Python is a row major programming language. Okay, MATLAB is a column major. I'm not sure R is which. You just try. You can just try. Okay. So why is different? Maybe I give you more detail. So do you know how a matrix is stored in your computer, in your memory? So you know the memory, RAM, right? What is the memory size of your computer? Usually it's like for that desktop, maybe it's 200 some gigabytes of no, it's too much. I think it's 8 gigabytes or 32 gigabytes, something like that. Your memory. You know what is a memory in your computer? Yes, you should know, because later when you do running machine learning method, you should be very careful on this. This is very critical. You should be familiar with the machine that you're working on, because it's very related to your machine learning method. Okay, for example, 32 gigabytes. 32 gigabytes in your memory. So 32 gigabytes is basically 32 times 1024 megabytes times 1024 kilobytes times 1024 bytes times 8 bits. Okay, so you have this many bits in your memory. Do you know how those memory are actually distributed, or how the computer organizes this number of bits? So remember that in the old ENIAC, it's a tape, right? So in the modern computer, it's still a tape. So basically, it's lines in a super long tape, and each of them is just 0, 1, 0, 1. Okay, this is how your memory store the data. Okay, then I'm storing a data that is 1, 2, 3, 4. Actually, I cannot store the data in a matrix because my memory is actually a tape. So what I'm going to store is that I'm using so one number, this one is let's say it's a 8 bits. So I'm basically here, I'm using 32 bits to store these 4 numbers. Actually, usually it's not 8 bits, it's 32 bits. Okay, so here I'm using 144. Okay, 128 bits store these 4 numbers. Okay, so how these 4 numbers stored is depends on the computer. Okay, depend on the programming language. If it's Python, then Python, so you need to ask the inventor of the Python why they store the matrix into 1, 2, 3, 4, row major. And some programming language, they store the matrix into the column major, 1, 3, 2, 4. So you can see that given a matrix, it's stored in a memory in a vector. Okay, so basically you don't change the memory, the order of these numbers in your memory, you just output directly. So that's why some some programming languages row major, it gives you the row major result, and some program gives you the column major result. It's just because of the inventor, how the inventor of this language decides how to store their matrix. Okay. Okay. So this is very important later if you are doing deep learning. If you are doing deep learning research, this will be a super critical issue that you will encounter every day. Okay, so now you know that you can so the function you are going to use is called flatten. So if you're interested, just search online. The function name flatten. So flatten means that you want to flatten a matrix into a vector. Okay. So then another question. How, if you really want to have this order, how you do it? So very simple, you just transpose and then flatten. Okay, you transpose and flatten, then you get this result. Okay, okay, good. Okay, so later in deep learning, I think I don't have time to cover in this subject, but later if you're working on deep learning, the matrix operation is extremely important. Okay, because usually the deep learning does not have a bug. The bug is something somewhere here. For example, your thought is this order, but the actual order is that, and you don't see any reporting error reporting, but your result is not good. It's mainly because of these issues. Okay, so I think I talk about images, and then I talk about the large language model. So this one, I think I already mentioned how you can convert a language into text. So you can see here, different word has a vector to representing this. Different token has a you decompose your question into tokens, and different tokens has a vector representing it. And then you put it into the machine learning, to deep learning. And then eventually you will also output the tokens, basically the output the location. And then eventually you can output this language. Okay. Okay, so when we talk about data, so this is basically how you format the data into a matrix. And then there are different type of data. I think I can quickly go through this part. So we have stationary data or time-dependent data. With time-dependent data means that we have some time series. Simple example, if you have a sensor reading data that you format into a matrix. So this is number of sensors, and this is the time intervals. Each row, this is actually a time series. Right? So given a sensor read, each of the row representing the sensor reading of a particular sensor, this is a time series. Okay. So you can draw the time series data like this. Say for example, here I'm drawing the traffic number of vehicles on the road. So here you can see that the x-axis is from 0 to 2023.55. And then you can draw the one row using one line. Okay, if you have multiple row, you can draw like this. So here you can see that I draw a lot of row in different days. So you see this fluctuation. Okay, and similarly, what you can do is that you can draw a data matrix like this. So here, basically, I'm doing each of the day as row and column as each of the time interval for each of the for one day. Then you can see the pattern of the data. And similarly, as long as you have a matrix, data matrix, you can draw something like this. Then you can see some pattern. Okay, so for those data, I think this I don't need to mention too much. Basically, you can calculate the mean, you can calculate the median, you can calculate every characteristic, and also you can draw some diagrams to understand the distribution of the data. Okay, so that's the first thing. So we talk about how we define a data. Okay, so I guess after this, you have a better picture. When you talk about data, you should have a clear understanding. It's basically a matrix. Okay. Okay. Then given this setting of data, then we need to talk about machine learning. Okay. When we talk about machine learning, the first thing you need to understand is that the machine learning has different category, and you should, given a task or you have your data and you want to do something, the first thing you need to identify what type of learning you should use. Okay, so when we talk about so we have basically we have three types of learning, and then before that we have a universal setting, which is the setting of machine learning. Okay, we call a machine learning method usually it has two stages. Okay, we call it training stage and testing stage. Okay, training 训练 testing 测试 okay, training stage and testing stage. Basically, in the training stage, we want to use the data to let the machine learn. Okay, so somehow you want the machine to learn, and then in the testing stage, we want to use this machine to get some output. Okay, so this is a so when we talk about machine learning, remember that it's always two stage, training and testing. Okay, so you need to have some algorithm to let the machine learn, and then after the machine has been learned, you can use this machine to do your task. Okay. Maybe I first give you the three categories. So based on the setting, so no matter which of the category you are doing, it's always training and testing. But we separate the machine learning into three major groups. We call it supervised learning, unsupervised learning, and reinforcement learning. Okay, so this is given a task in your research, the first thing you need to be very specific which learning category it is. Okay, supervised, unsupervised, reinforcement learning. Supervised is called 监督. Okay. Okay, so let's say supervised learning. So basically, supervised learning says that in the training stage, we have X and Y, and we want to find a function, a machine F, such that the X, we input the X into this machine, into this function, and then we get the outputs of Y. Okay, so this we call it supervised because we know the answer in the training stage. Okay, and then in the testing stage, we only know the X, we don't know the Y, but because we have already trained the F very well, then we can use the F to output the FX. Then we can get the Y. Okay. Okay, so based on the Y, there are two types of approach. If Y is continuous, for example, we want to predict tomorrow's stock price. So it's a continuous number. If it's a continuous number, we call this task a regression. okay, regression. And if Y is discrete, for example, whether this is cat or dog, or basically it's discrete means 0, 1, 2, so it's cat, so it's more like a indicator. So then we call this task a classification. Okay, so supervised learning basically has two types, regression and classification. Okay, let me give you several examples. Okay, so for example, this one, I want to predict the house price in a city. Okay, I want to build a machine learning model to predict the house price of a city. What you're going to do is that in the training stage, you need to collect the data like this. So you need to collect some data like this. So basically, this data contains, for example, the price of the house and then some features of the house. The feature include like the number of rooms, the area, and the location of this house. So we say this is X, and then this is Y. Okay, so in the training stage, you can see that we have the X, we have the Y, and both are matrix. Y here you can see it's just a vector, and the X is a matrix. And then we are building a function from X to Y. Okay, so we build this function, we can train this model. So first, this is a regression. Okay, so this is a regression because the price is continuous. Okay, so this is a regression in Chinese called 回归 regression problem. Okay, and you input X, and then you have the answer Y. So you have X and Y, you train this. But the training of machine learning, you actually haven't used it. So why this model is useful? For example, later you have a new building that will be built, and then you can collect the data of this part. Even this new house, you can also look at what is the area, what is the size, what is the number of room, and then you can predict what is the price of this house using in the testing stage. Okay, so the machine learning model is useful in the testing stage, but actually, when you train it, you actually haven't used it. The training is just you just want to find a F model, F function to match X and Y. Okay. Okay. So this is a regression problem. And another one, this one is also very popular, very widely used. We call it a spam detection or image classification. So basically, given an image, your Gmail or Outlook will run a machine learning model to distinguish this email, whether this is a spam or not spam. And if it's spam, then it will automatically goes to spam or junk box. Otherwise, it goes to your inbox, right? So here you can see that this is a supervised learning. And also, this is a classification because your Y is yes or no. This is discrete. This is a classification problem. Okay, so here, what the data you have is basically this email. And this email somehow is converted into data. And then the output is yes or no, 0 and 1. Okay, for example, you collect the data of this different email. In Google, for example, they collect a lot of email. And those email, they summarize the feature of this email. Okay, and then you know that whether this email is a spam or not spam. Okay, so you create this XY pair. Then you use this XY pair into the machine learning, you train a machine learning between X and Y to get this model. And later, you use this model to determine whether the future email are spam or not spam. Okay, so this is a classification problem. And similarly, you have a image classification problem that is basically, if you, for example, I want to build a machine to differentiate cat and dog, and to distinguish cat and dog, then my output is either it's a cat or it's a dog, right? So this is classification. Okay, so basically your input is a vector, your input is the data and the output is a so here you can see that we want to output a 10-dimensional vector. So this is one hot. Because you remember one hot. One hot means that you output other to be 0 and then to be output this to be 1. Because you don't want your machine to output cat directly, it's impossible. You want your machine to still output a vector. Okay, so we are using the one hot. Okay, another one is trend prediction. Basically, for example, you want to predict tomorrow's temperature. You want to predict tomorrow's stock price. You want to predict anything that is in near future. Okay, so you can think of this as this is a supervised learning. Why? Because you can have a lot of data that is in the history. For example, you think of you are standing at here, then you have the future results here. So you can formulate this as a supervised learning by using the historical data. And then once you have trained this model, you can use at the current time being, then can predict the future. Okay. This is widely used in everywhere, no matter it's in congestion prediction, stock price prediction. In Hong Kong, actually in Central, many people they are developing machine learning model to predict the stock price so that they can make money from it. Okay, so this is actually pretty common. Well, this is a large topic, how you predict the future trend. I think in many of your research, this might be useful. Okay, if you want to know the short-term future in the future. Okay, so you can develop a machine learning model to do this. Okay, so when you do this prediction problem, usually we need to use a approach called rolling horizon. Rolling horizon basically means that, for example, you are currently at 8:15, then you are going to use this history as X, and then this will be your Y. And later, after 15 minutes, it becomes you are using this area as X, and you use this as Y. So you can see that you are doing one step by another step, and every step you use the past as the input, and then you want to predict the future a little bit. Okay, so in general, you can see that this is X, and this gives you the Y. So you can formulate the X and the Y pair for training the model. So this is a supervised learning, and this is a regression problem. Okay. And for example, in many transportation applications, this is very useful, like in Didi and Uber. They use this to predict which area will have more passengers, so that they can send those information to the drivers. Drivers will go to some specific locations to pick up passengers. So this is widely used. Okay, so this is supervised learning. So you can see that supervised learning has a very specific task. If you want to do something, you just collect the data. Okay, for example, you want to recognize in your area, for example, you want to do some computer vision task. You just collect the video and then mark the video. You have sufficient data to train your model, and then you can use your model in the future. Okay, so supervised learning, very straightforward. It has a very specific thing that you want to achieve because it has a why, right? So unsupervised learning is a little bit tricky. The unsupervised learning means that you don't have why in your training stage. So here you can see that for the unsupervised learning, you only have a X matrix as a data, but you don't have any targets. What they require is that you just try to find some special property and characteristics of the data. So there's no specific requirement. And also in the testing stage, we just check whether the new data has the same property or characteristics. If it is yes, that means you learn something from the data. You learn some pattern from the data, right? But actually, it's unspecified what type of data, what type of property or characteristics you want to find from the data. Okay. So basically, unsupervised learning is actually much broader than the supervised learning. Well, if we want to say like this, for example, if the supervised learning is something like this, then unsupervised learning is actually much larger because there are so many tasks in the unsupervised learning. So we cannot give you a full list. Okay, so there's so many. Okay, but supervised learning is very specific. Regression and classification covers all. Okay, so unsupervised learning here, what I can do is I can just give you several representatives. For example, a very popular or famous unsupervised learning method task is called clustering. Clustering in Chinese is called 聚类. Okay, so how do I interpret from a perspective of data? So the task of clustering is basically that you are given a data matrix, and I want to group the data into different groups, and for each of the group, the data inside should be similar, and between the group, the data should be different. Okay, so this is the task of clustering. How do I interpret in this matrix form? Okay, so basically you are given this matrix X. So what I want you to do is that you pick some of the row that they are in the same group, and you pick some other rows that are in another group. Okay, and I want that for the same group, the data should be similar pattern. And for the data that is in different group, they should be in different pattern. So this is a task for the clustering. Okay, so we don't have any targets. Okay, so here you can see that we just try to find the pattern within the data. Okay, this is called clustering. Clustering, I think, is pretty famous or popular. Do you know the famous clustering algorithm? Anyone? K-means, have you heard about this? Yes, right. So this is very standard clustering algorithm. So basically, it's using the pattern of the data to get the clustering. So this is pretty useful in data analytics, actually. So I think in your research, maybe you are going to use this. Okay. And there's another one. So you can see that the clustering. So this is mathematical description. So you can see that you have x1 all the way to xn. And you want to find groups of the x1. You want to put the x1 or xn into different groups. Okay. So for example, why this is useful? Say for example, you have the usage pattern of different customers. For example, electricity usage. And then you run the clustering. You can understand that those group of people, they use electricity early, for example, and those people, they stay up late, they use like energy later. So basically, you can have this kind of profiling for the people and for the different data. Okay, this is quite often used in many research papers. Okay, because it gives you a lot of insights. Okay. Okay, so clustering, but as I just mentioned, there's no why for clustering. Means that you don't have a answer. You don't have a, I shouldn't say answer, you don't have a ground truth for the clustering. For example, this is a very simple example. Here you can see that I have a lot of people in symptoms. Not sure you can watch this and cartoon or not. So here I want to run a clustering algorithm for those people. So it actually has different criteria. Then you have different results. For example, I cluster those people by whether they are in the symptoms family or not, or I just cluster by gender. So the results will be different, but they are all valid clustering results. Okay. And in some cases, for example, in some image, you can also do a clustering so that they can identify some tissues that is not not very normal, or that is some special tissues. based on the image. So you can also do the clustering for this one is clustering of pixels or clustering of images. This is quite useful for a task called anomaly detection. Not sure. Have you heard about this term? Anomaly detection. In Chinese called 异常检测. Okay, so basically after the clustering, if some data that is in a very distant or very unique cluster, so that data is usually an anomaly. Okay, so this is clustering. Another one called dimension reduction. Dimension reduction, let me also use the matrix to illustrate. Dimension reduction. So basically you are given a matrix X, right? N by D. What I want to do is that I want to convert this matrix into another matrix that is N by D prime. And I want D is significantly larger than D prime. Okay, means that you want to reduce the size of the feature. But for example, for this data, I still want the information is preserved. For example, later I use this new data to run a supervised learning algorithm. I want to run some algorithm. The performance does not change much. So this is called dimension reduction. Okay. So essentially, the key idea of dimension reduction is that we want to compress the information. Okay. So the dimension reduction is actually heavily used in everywhere. I give you a very famous and also very famous, very interesting example. So here I'm talking about a data set, but this data set is also very famous called MNIST. MNIST is basically a data set of a lot of handwritten digits. Handwritten digits. Okay, do you know where this is useful? It's using the check. Maybe you haven't used this a lot in China, but in Hong Kong, actually, people are still using check. Check. Okay. So basically, in the check, you just write how much money you want to pay to a person, and then they will input this check into the ATM, and then the ATM should automatically recognize the handwritten number in the check. Okay, so those handwritten numbers are basically from 0 to 9. So you can see that here the MNIST data set contains a lot of images. So this is one single image. Okay. So this is one image. You can see here. I forgot the pixel. I think it's 90 by 90. Maybe others, but basically it's let's say it's 19 by 19 pixels for this image. You can see that they have a lot of images. Okay. So how many images do they have? They have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 160 images. Okay, so as I just mentioned, I think we already discussed for this data matrix X. So you can formulate this data matrix, right? So in total, you have 160 image as N, right? And each of the image is 19 by 19, which is 361 pixels. Right, so here you can see you have so many images. In total, we have 160 images. Okay, 1, 2, 3, 4, 5, 6, 7. So one row is 16. Then in total, 160 images. Okay, and each of the image is 19 pixel by 19 pixel. Okay, so I think we discussed this, so you can see you have a data like this, 160 times 362. Okay, so let's say we want to run a dimension reduction algorithm for this matrix. And what we want to do So this is n by 160 by 261, right? So we run a dimension reduction. Remember that the dimension reduction does not change n. So the number of data does not change. It's just the feature, the size of the feature change. So let's do it very extreme. Let's change it to 160 by 2. Okay, let's do it very extreme. We compress the 361 dimension data into 2 dimension. Okay, why we are doing 2 dimension? Because the 2 dimension, we can draw it on the paper. Okay, 2 dimension, right? So this is X and Y. So say for example here, I put it into a XY coordinate. So each of the data here is actually 1 point on this plane, on this paper. So basically that means you project, you map each of the image, each of the handwritten digit into 1 single point on the paper. Okay, then you can plot all those images as dots, as a point. So then you have this figure. Now I think you can understand this figure. So basically you have a lot of points. So the evidence data is pretty large. I think it has thousand of the image. So you can see that you have a lot of dots on this figure. Each of the dots representing 1 image. Okay, and they color different dots by its original digit. If it's 0, it's colored into this one, and if it's 3, it's colored into this one. Okay, so remember that this is after the dimension reduction. So you can see that there's a very interesting pattern that you can find. You can see that here, 0 is quite isolated here. Okay, and then you'll see some interesting transition. So here you can see these are ones. These are all 1. And there are some 1 is a little bit tilt. And then this one is quite close to 7. Okay, and then you'll see that 7 has different writing pattern, but there are some 1 is written like this. Then this one is very close to 9. Okay, and also you'll find that 9 is actually close to 4. Okay, and also here you can see that 8 is closer to 2, and also 8 to closer to 5. And also 5 similar to 3 and 6. So roughly you can see that after this dimension reduction, you draw this, you draw those images into this, you draw this plot. Actually, you'll find some patterns that's you never, you haven't, you are not aware in the past. You see those, how those images, they transition from one to another, and how they are similar or not similar. Okay, so this is very one of the very important application of dimension reduction, to draw the figures. Okay, to draw the data patterns. So because the high dimension data you cannot draw, but if you compress it into 2 dimensions, you can draw it on the paper. Okay. Okay, so basically, the dimension reduction is that you have the dimension of D and you want to reduce it into K. Usually, the dimension reduction, after the dimension reduction, actually, you can still use this data for supervised learning. You can still do classification problem, you can still do regression problem. Okay. So in general, we believe that the dimension reduction can help you to visualize the pattern of the data. And also it can give you there are some paper says that after dimension reduction, the noise can be reduced. It's hard to say. It's hard to say, but that someone's argued this. You can try on your data set. Okay, so we talk about supervised learning, unsupervised learning. So basically, unsupervised learning, you need to specify the specific task. There are so many unsupervised learning, so you cannot go through all of it. Okay. And the third one, which is called reinforcement learning, this one is a little bit more complicated. Okay, so the reinforcement learning is not talking about X and Y. So this is a brand new setting. So reinforcement learning is talking about a machine that is interacting with a environment. So in the reinforcement learning, there are three things that you need to define, which we call it state, reward, and action. So in general, you'll find that the supervised learning and unsupervised learning is actually one shot. Means that you give me X, I give you Y. Or you give me X, I give you some pattern. Okay. Only the reinforcement learning is about sequential decision. Means that you cannot you not just give one decision. You need to you need to provide multiple actions. Okay. So this is a key feature for the reinforcement learning, the sequential decision. So that means the reinforcement learning is particularly useful for the control problem. Because when you do control problem, usually you have to control some agent continuously. If you want to control something continuously, then this is more like a reinforcement learning. Okay. So the reinforcement learning basically talking about a machine, an agent that perceives some state. And then based on the states, the agent will take some action. And then given this action, the environment will provide a feedback. Okay, based on this feedback, we call it reward. Based on the reward and the new states, the agent will provide a new action. Okay, so this is a loop actually. So basically you get the states, you provide action, then you get feedback, you get the new state, you take the new action. So in general, we believe that the machine learning algorithm during this whole process, the action will be better and better. Okay, so this is a whole, the learning process is like this. Okay, so this is no, it's not just a one-shot decision, it's a sequential decision. You have to make multiple decisions and getting better and better. Okay, so here we are saying that the machine that is using the reinforcement learning, we usually call it an agent. Agent means that this is some entity that can understand understand the environment, and then it can act on the environment and get some goal. It has some goals. So this is a very interesting video I just show you. So this explains what is it's not here. It's okay. Maybe I'll show you next time. So basically, this shows you how a agent can react to the state and then take actions and get reward. Okay. So basically, the reinforcement learning is widely used in a lot of control problems. For example, controlling the robot. Okay, like the unit tree. You know the robots in unit tree. So basically, those are all using the reinforcement learning to control the robots. Okay, and in some cases, for example, you can use the you can use the AI reinforcement learning to play a game. So basically, you are using the reinforcement learning to control the controllers. Okay, so this is a very famous paper that they are using the reinforcement learning to play the Atari games. I guess you are so young, you don't know what is Atari games. So it's like a very old game, much older than Switch and PS. Okay, so very old game console. Okay, and so this is actually the paper that's the first demonstrate the power of reinforcement learning. And the same group of people, they developed the AlphaGo for the Go game. Okay, because the AlphaGo is similar process. You just make decision one stone by another stone. So this is a very standard reinforcement learning. Okay, and also, for example, you want to control the autonomous vehicle, you also need to keep control the vehicle, whether turn left or turn right, or speed up or slow down. So this is also can be done by reinforcement learning. Okay, so the AlphaGo is mentioned. So basically, the AlphaGo is using the reinforcement learning to play stone by stone and keep evolving by itself. Okay, so that's basically the three category that we want to discuss. Supervised learning, unsupervised learning, and reinforcement learning. Given a task, for example, in your research, you want to use AI, you want to use machine learning. The first thing you need to determine which type of learning it is. Okay. So in general, as when we talk about supervised learning, if it's a supervised learning, the first issue is that you need to ask yourself is, do you have sufficient data? Okay, because when you do supervised learning, you need to have why for supervision. Okay, so different tasks, depending on the level of difficulty, the number of data required is different. Okay, the more difficult of the task, the more data you need to have. Okay, so in general, supervised learning has some feature like this. And the supervised learning has a regression and classification. I think this is very clear. And for unsupervised learning, the issue is that it does not have a goal. It does not have a object. So you need to know as much unsupervised learning task as possible. Then you can see whether your data is suitable or not. And the reinforcement learning, very straightforward. It's used for engineering control problem. As long as you have something to control, reinforcement learning will be very useful. Okay. From my experience, if you want to use AI into your domain, most of the depending on how well your AI, your in your domain. I know some domain they have integrated with AI very mature. They have been doing this for years. And some area, even the very simple AI method can publish a very good paper because not too many people are working on that. Okay, so depending on your area, from my experience is that if your domain is in an early stage of using AI, most of the tasks will be in the supervised learning. Okay, if it's in the early stage. Okay, because you have your domain data, right? You can easily fit a supervised model, then you get some results. Then you can publish papers. So that's the first premature stage. You can do something like this. But later, more and more people doing this, you'll find that most of the data in your domain has been published in the supervised learning. Then you have to come up with some other things that you want to publish. For example, if you want to if you want to use reinforcement learning algorithms, usually you need to have a simulator in your domain. For example, you want to control something, but you cannot control in real world. It's too costly or too complicated. In most of the cases, you need to develop a simulator by yourself. For example, you want to control the vehicle, then usually we will have a driving simulator. And if you want to control, for example, control the charging, control electricity grid, then you need to have some model, some simulation of the electricity grid first. Because when you do reinforcement learning, it's an interaction, right? You need to interact with something. Usually that is a simulator. Okay, so you can think of in your domain whether there are some simulator and you want to work, you want to control all those. I know there are many papers related to controlling. The simulator is some CFD model simulation, the finite element model, and then they use the reinforcement to control, for example, the wind, to control the heat, something like that. Okay. Unsupervised learning, I see papers in classroom. Okay, so I only see paper in classroom. Others I don't see too much. Okay, so based on my experience in reviewing the AI application papers, but I highly suggest that you know more tasks and then you try to see which one is suitable for your domain. And then you can try to think of the first type of the AI paper. You just use those methods to your domain and then see some insights. And once you finish that part, maybe you can think of the second type of AI paper to develop some new method to get to improve the accuracy, to improve the performance. Okay. So this is another figure. I think I just cover what I'm talking about today. So basically, it's 3 types, and different type has more application. But remember that this three type is not exclusive and it's not exhaustive. Okay, actually there are a lot of other settings. Okay, I'm just talking about the three major categories. So there are actually a lot of other type of learning schema. So maybe I give you some example. There is one type called semi-supervised. Don't know what is the setting of semi-supervised learning. It's actually very easy to understand. It's basically you have a lot of X, but within those X, you only have a part of Y. So for those data you have Y. For other data, you don't have Y. So this is called a semi-supervised learning, half supervised, half supervised. Okay. So there are other settings, for example, active learning. Active learning is basically said that you have some X, you have some Y, and you ask your machine to learn from this data, and then your machine can determine what is next X you want to have, and then you provide Y. It can actively search for the new data for learning. Of active learning. So there's so many, so I cannot enumerate all of this, but you can see those are all the integration of the existing type. Okay. So the last page. So in addition to this three type, I think recently we're talking about generative AI, Gen AI. So the generative AI, when we train this model, it's actually very complicated. If later we have time, I can give you more detail of how you can train a generative model. So, but this is actually a brand new schema. So the generative AI, when you want to use it, actually you are using some prompt, right? So you input something to the model, and then the model gives you something out. So this is a new schema. So I just put it here. We don't say whether a generative AI is a supervised learning or unsupervised learning. We just say it's a generative model. Okay, so it becomes a unique category. Okay. Okay, so I think so this is the first lecture. I just try to give you some of the just two things. First thing, how you organize the data. The second thing, what is the category of the learning? Okay, then starting from next week, I think I will talk about more details of the machine learning method. I just try to find some select representative model in each category, and we'll talk about the detail. Okay, hopefully this can give you some flavor of the model. And after today, I think this this website becomes more easy to understand for you. So here you can see that it's organized by classification, regression, clustering. For example, go to classification. Those are all the methods in classification. Okay, so no matter what type of method you have, you just provide X and Y. Then you can try different methods. Just change one single Python line. You can switch to a different model. So it's a unified input and unified output. Okay, so I think that's it for today. We don't have homework this week, so I see you next week. Okay, so if you have any question, let me know. Okay. I think today's is easy, right? So easy to understand. Starting from tomorrow, I think there will be more equations.
Yes.